Now we have two other functions we haven't talked about. We need to graph the cosecant of x and the secant of x. And these are the reciprocal functions of the sine and cosine respectively. Now if you are graphing the cosecant or secant, depending on what it is that you need to do, you always need to graph the sine, the guide function first. So what I'm graphing first, before I can even graph the cosecant, I'm going to sketch a graph of the sine of x. We know how the sine looks like. We go from 1 to -1. The sine starts at 0, then goes up to 1, 0, -1, 0, and we can go to the left as well. So this beautiful sine function more or less looks like so. Now why do I graph the sine function first? Again, the sine function is your guide. Your guide to what? To know where the asymptotes are. You know that the cosecant is 1 over sine of x. So whenever the sine of x is 0, that means the cosecant is undefined. So in order to get the correct graph, I have to have the sine functions, and then I draw my asymptote through the points where the sine is 0. Where's the sine 0? Right here, there, over here, and there. So these are all asymptotes. Make a dashed vertical line, yes, through the axis. Here you go. These are my asymptotes. Now, the easiest way to actually graph the secant is draw parabolas. You draw parabolas that are either opening up wherever your maximum is. So the actual cosecant function has to go through pi over 2, 1, but then your parabola opens up like so. And of course you can't touch the asymptotes. Now if you have a minimum on the sine function, again you go through the 3 pi over 2 -1, and you draw your parabola that opens down. And you do the same over here on this side. You draw your parabola. Here we have the same point that opens down. So that is your cosecant function, the basic cosecant function. The period is just like the sine function, is 2 pi. We have a domain here. The domain, we got to be careful because we have asymptotes here, is all x values that are not, and we are excluding the n pi x values because each n pi times we have an asymptote. So if 2 pi is my last asymptote here, the next asymptote would be 3 pi, 4 pi, and so forth for a basic cosecant function. The range, now let's take a look at the range of my y values. So we go from -infinity to -1, and -1 is a bracket because we do have a point here, and then we have a gap, and then we start at 1 and we go to +infinity. That is your domain. So this is the graph of a basic cosecant function. Now let's take a look at a secant function, very similar. Instead, now our guide function is the cosine. So y equals cosine of x. How does a cosine look like? Do you remember? Cosine starts with 1, then we go through 0, then we go -1, go back up to 1, to 0, and then to 1. Of course, we can do the same here on the other side. So this is 1 period, oops, that didn't sound good, -pi. So let's just go, here you go. This is 1 period and a half of the cosine function. That will be our guide. Why? Because 1 over cosine is the definition for the secant. Now we do the same thing we did here for the cosecant. We draw our asymptotes first. Every time, each point where the cosine is 0, we draw our dashed vertical lines. These are our asymptotes, just like so. And parabolas, where we have a maximum, a parabola opens up. Make sure that you touch the 1 point, and where you have a minimum, the parabola opens down. And here we have half of a parabola. Beautiful. And here we go down with a parabola. So the purple graph is the secant graph, and we use the cosine as the guide function. The period is still 2 pi, but now the domain is all real numbers except x cannot be, look, n pi over 2 times. So x is not defined for pi over 2 plus n pi times. Every n pi, so pi over 2 plus pi plus pi plus pi, you have an asymptote. Of course, the range is the same. The range is going from negative infinity to 1, union from 1 to infinity. So very important, graphing a cosecant function, you have to graph the sine as your guide function first, and then put your parabolas on bottom and top. And for a cosine, you need to, for a secant function, you need to graph the cosine function first as your guide.